Okay, the next step for today, not the last step overall, but the last step for today is going to be to add information about genotype to your pedigree chart. So in the end, it's going to look something like this. We still are going to have these colored or uncolored symbols indicating whether or not the individual shows the trait. But now you're also going to try to figure out what the genotypes are. There are going to be some that are easier than others. What you're going to start with is, what is the recessive condition? The recessive condition, all of those individuals are going to be homozygous recessive. They have to be. If you have the recessive condition, then you have to have 2 recessive alleles. So on this pedigree chart, you can see that every individual that's colored in is homozygous recessive. The genotype is homozygous recessive if they show this trait must be a recessive trait. And then after you've done that, you know all the other individuals show the dominant trait. They are either going to be homozygous dominant or heterozygous, and sometimes you can figure it out. So here, for example, this individual, they don't know. This individual has the dominant phenotype. They might be homozygous dominant. They might be heterozygous. Same with this individual. But whoever made this pedigree chart figured out somehow that these 2 individuals were heterozygous. So I'm going to go through a real example right now with you so you can see how that would work. This is going to be for freckles, and this was for one of the students in the first period of class. And what we discovered, interestingly, because having freckles is relatively rare, but it turns out that the allele is dominant, which means that if you have a phenotype where you have freckles, your genotype might be homozygous dominant, where you have 2 dominant alleles, or you might be heterozygous, where you only have 1 dominant allele. Either way, you'll have freckles. Whereas if you have no freckles, that's the recessive condition. In that case, you have to be homozygous recessive, and you have to have 2 recessive alleles. So we can go through this chart and figure out what things look like. In this case, the student who was female has freckles, and nobody else in her family does. And so what we were able to figure out from this was, well, if she has freckles, sorry, the other way around. She has no freckles, and everybody else does. Sorry, all her siblings had freckles, and she did not have freckles. So we know, since she has no freckles, her genotype has to be homozygous recessive, and all of these individuals have to have at least 1 dominant allele. And then her dad has freckles, but her mom doesn't. So her mom has to be homozygous recessive, and the question is, what is the genotype of the rest of these individuals? And this is where we can use some logic to figure it out. We actually can figure out all of them. So we know that every single one of these offspring got 1 allele from each parent. That means they got 1 of their 2 alleles from their mom. Their mom has 2 alleles, but they're both recessive. These individuals have to have 1 recessive allele. They must have gotten it from their mother. The father has to have at least 1 dominant allele, but the father could be homozygous dominant with 2 dominant alleles, or heterozygous with 1 dominant and 1 recessive allele. But we know that the student got 2 recessive alleles. she got one from her mother, and she had to have gotten the other one from her father, which means we know that the father's genotype must be heterozygous as well. Sometimes you can figure it out, sometimes you don't have enough information. Sometimes you can't tell. They might be heterozygous, they might be homozygous dominant, you can't tell. What I want you to do next is put all the genotypes you can identify and figure out all the ones that you can. The ones you'll be able to identify right off the bat are the homozygous recessive ones. If they show the recessive trait, they have to be homozygous recessive. The dominant phenotype individuals might be heterozygous dominant, they might be, homozygous dominant, they might be heterozygous, and you can often determine which of those it's going to be, right? So that's your next step. We'll take 10 minutes here because we're at the end of the period.